Okay, so just in case you haven't read any of the text or the big red warning at the beginning of this video, you absolutely must correct the machine origin offsets in Z. For whatever reason, this version of firmware, which is 1.10.1, it changed. It seems to have lost some offset somewhere at some point in the code pipeline. Don't really know where it is or why it needs doing. But if you don't do it, you'll get a nice bed calibration mesh and everything, but as soon as you start to do a print, it'll just try and drive the nozzle into the bed and damage your bed. So you absolutely must do this M206 command and put a Z offset in there of -7 or 8 mil. There's more detail at the end of the video around the 16-minute mark, so please do that first before you do anything else in this video. Okay, so this is a video on how to get bed mesh leveling sorted very, very nicely on the Snapmaker. There's been a few issues with different firmware versions, different revisions, and the latest firmware, which is 1.10.1, they've added in some extra commands and allow you to do a bed mesh level grid size of up to, I think it's 12 by 12 points. So I'm going to show you how that works. So we're going to connect to the Snapmaker first. I'm going to use YAT, which is a freeware basic terminal emulator. It's pretty good. So that's the ports. So we'll connect. And I should thank some of the people on the forum. There's a lot of good information already on the forum out there. Where's that window gone? There we go. I think Tone's done quite a bit. His handle on there's Tone. There's a lot of information on there already. But this is just to try to collate it all into an easy to follow-ish video. Okay, so I connected to the Snapmaker. And what's happened in the new version of the firmware is we've got this extra command now. Let me find it. Where are we? This G1029. So it takes a parameter P, which defines the grid size, A, which starts the bed mesh probing even. S allows you to set the offset at the end. You can individually address points in there if you want with I and J notation. We'll come on to that later, and set individual point values as well. So quite a powerful tool, and good that they've included, made the bed size of the mesh much bigger. So first thing I'm going to do is set the mesh size. So G1029 P. I'm going to set it to 10. So that's 10 by 10 points. Now I'm going to set my Snapmaker away to go and run that. So the next command is G1029 S. No, it isn't. So the next command is G1029 A. And you probably can't hear it, but the Snapmaker in the background is starting to do its thing. So we'll come back when that's finished. So there we go. It's doing its own procedure, and now it's starting to probe the grid. I'm not going to record all of this process because it takes a reasonable amount of time with it being a 10 by 10 grid. We'll just record a few points just to show you the resolution that it's doing the grid at now. So there we go. So you can see it's a pretty fine grid that it's doing. Obviously it probes each point 3 times and stores the value. So that's going to take quite a bit of time. And you can see in here, if we just set the commands again. So one thing you need to do is set the text settings. So the end of the line sequence needs to be line feed only. We'll do that. OK it, and there you go. You see the text is now formatted right in YAT, and it's starting to probe each point. It tells you each of the point values it gets each time, which is pretty consistent. Like I say, yeah, we'll come back when it's finished because it's going to do 100 points. Okay, so that procedure's finished now, and we've got, you can see it's done 99, 100 including 0.0 bed probing points. And it's now in the position where it wants you to define the offset. So we'll do that, and you can move the nozzle down to the bed, and then run a G1029S to store the offset. So yeah, so we're just doing the offset now. So I've just used a piece of paper, and I'm just going to move the nozzle down. So it's very similar to like you do if you're doing the 5x5 grid on here. And just keep going until it just starts to bind on the piece of paper. So I think one more. That's it. So it's just a bit of resistance on the nozzle now. So now that we've done that, we'll go and define the offset with the G1029S command. Okay, so we've adjusted the offset on the printer, and now just run a G1029S. Let's just get the mouse back in there. G1029S. And that will store the offset. There we go, whatever it was, 1.2. Okay, so one of the main benefits of doing it in this YAT window is now if we run an M420V, that will display all the points that have been saved. There we go. So there's two sets of tables here. First table is all the points that we've just recorded, the 100 points, and then there's some subdividing that goes on to make it even more fine using this Catmull ROM leveling grid. But the points we're interested in are these here. So what you can do now is you can highlight that, which you can't do in the Luben interface. This is the benefit of doing this. If you're not using any other kind of Octopi or anything like that, you can just grab those, copy that, copy to clipboard, and if we go into Excel, and paste, and then go on to use text import wizard, delimited, using a space, there's all the points. So what we can do now is draw a surface plot. So you just highlight all the points, go into insert chart, select a surface plot, I'll just click finish. There we go. So it looks slightly out at the moment, that's because the data series you need to adjust to not include the axes points basically, so we'll do that. And there's the grid. And if we just change these so that is, whoops, just put X1 on that one. I think which one's which, X1. So I just need to remember which ones are which. I'll be back in a second. So yeah, I just have to quickly remind myself on Excel there what's going on. So yeah, so basically what you had to do was right click on here, do source data, x-axis category labels, and then select rows. Okay. For completeness, Yeah, and you could go and change all these series names as well to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Can't be bothered doing that. So you can see the grid. The bed's not too bad actually. There's a couple of drop-offs here and there. But actually, if you just format the chart again, 3D view, you can alter the view a little bit. So I'll just spin it around a little bit more. Add a bit more elevation on it. Spin it around a bit less, maybe. Something like that. There we go. Apply that. Okay. So yeah, there's a little bit of a drop off at the front of the bed, and then there's this blob here. Okay, so this is running some bed test G code now. So it's generated via Cura. Just get rid of those. It's there. Using my own Cura profile. So it does a little mini purge at the front of the bed, and then it will start to draw the outline of a large skirt for a very large square box, and the rest of the box is edited out the G code. So in terms of offsets on here, oh, we don't want a Z offset. Make sure that's nothing. We've got 0 Z offset, so this should now show the bed adhesion from the base, basically without any offset override applied. So let's have a look. So this was from something that I'll come back to and explain a little bit later. There we go. That's actually looking pretty solid at the moment. We'll see if there's any area where it's not really adhering to the bed, and we can tweak the values that were got by the auto probing. But it's not looking too bad. Perhaps that back corner there is looking a little bit thinner than the rest of the line. So we'll let it just do 2 circuits and then see how it is. This is basically just PLA on a 70-degree heated bed. Let's see what happens. So there we go. I think it does 3 circuits, but we'll pause it at the end of this one. I'll just go into here, so we'll pause it. It should pause when it's finished its G-code buffer. There we go. Let's see what we've got. So let's see. So I'm just trying to rub this away. That's arguably pretty good, and if I pick at it, there we go, let's pick it off. So actually, that's pretty good. So those outliers that I called them in the mesh graph on Excel they're actually accurate. That is the shape of the bed. This problem here was when I upgraded firmware from, well, I think it was 1.8 to 1.10. and I've tried to do this bed mesh leveling, and it just drove the nozzle straight into the bed. And it seems, for I don't know why, it seems for whatever reason I've had to put an axis offset in of about 7 point something mil. It's almost like it's lost the tool offset that used to be in there in previous versions of firmware, and it's quite annoying. It drove it into the bed. Luckily it's double-sided, and you can see there's a few points where it started to drag the nozzle across before it got to here, and it's done it a bit here as well. So yeah, I'll show that you've got to do that as well. Just a bit frustrating. You might well have noticed, if you've upgraded from previous firmwares to this version, that when you do the automatic bed mesh leveling via the hand controller, when you have to move the head down to the bed, it starts quite a way away from the bed. Funnily enough, about 7.5 to 8 mil away from the bed, whereas in the new version of the firmware it doesn't do that. It starts, as you saw before, very close, perhaps like a 1.2 mil I think it was, away from the bed. So it's almost like whatever's happened in the firmware, or somewhere in the calculations in this upgraded firmware, it's lost this inbuilt offset of 7.5, 7 point whatever mil in the calculations, and it just causes the nozzle to be driven straight into the bed when you start a print. It's quite frustrating really, but yeah, I'll show you what you need to do to sort that out. Okay, so first we need to get the firmware values up. So we're putting an M503 command. They're all case sensitive, these commands, so we need to put an M503 capital M. Okay, third time lucky. And there we go. You see there's an enormous list of G29 points in there because we've done an 100 point bed mesh leveling. So there's a lot of them in there. Anyway, so this M206 command here has got these offsets in for X and Y, and I've had to put an offset of Z, which is around 7.7 mil. Now I can't remember with previous firmwares whether it has a Z offset of 0 in it or not, but this seems to be one way of fixing it so you don't get the nozzle diving into the bed. So I'm going to change that Z value there, and the value that you need to use is basically based sort of like it's probably an average of these values, but or basically a value that's sort of around whatever the middle of the bed is, where it's all generally level. So around, I've used 7.7. So there you can see it's got a minus 7.7 in there, and that'll definitely ensure that the nozzle doesn't get driven into the bed when it starts the G-code print, and it should pick up all the bed mesh leveling points and whatever the offset was we set when we were doing the bed mesh leveling, and it should just work. So I found the value of minus 7.7 works quite well for this. So yeah, so the way you would edit it, which you might as well do just for the completeness, you'd basically type M206 Z, and then we'll put minus 7.7 or 8 in, something like that. Make sure it's all in capitals. So there we go, M206 Z minus 7.8. Hit return. Then do an M503 again to see that it's actually stored the value. Scroll up the list. There we are. Yep. So now it's minus 7.8, but I don't want it to be that. I'm going to put it back now for my printer back to minus 7.7. And then to make sure whatever value you put in is stored, you do an M500 at the end, and that will store it. And then just double check it's stored. So yeah, so that is how you put the offset in and stop it diving the nozzle into the bed. Be interested if Snapmaker maybe want to comment on this as to why I've had to do what I've had to do. I'd have thought it would have been known and be built in so that when you do your grid bed mesh and you set your offset, that it then doesn't try to 5, 7 mil below what all the settings you've done, but I'm not sure. Anyway, hopefully this gives you much better bed levelling and much better first layer adhesion. Let me know in the comments or on the forum what you think. Cheers.